So today's lesson is on percent. Percent is a proportion. So in the previous video, I discussed proportions. So you will probably want to look at that before you take a look at this lesson. So I hope to teach you a variety of strategies throughout the course to solve different types of problems. One strategy that we can use to solve problems where percents are involved is by thinking of it as a proportion. Right? So let's start with some basics about percent. So whenever you see the term percent, that really just means out of or per 100. Right? So what do I mean by that? Well, if I say 75%, what I really mean is 75 out of 100. And notice this is a ratio, really. And so I can use that ratio of whatever the percent is to 100 to help me solve problems. Now, of course, there may be other ways that you prefer to solve percent problems, but this is a strategy that can be used effectively. So let's look at a question involving percents. So in this case, I say 25% of student population likes chocolate milk. If there are 500 students attending the school, how many of them like chocolate milk? All right, so I've chosen this example because the numbers are nice and friendly, and I'm going to set this up as a proportion. Remember, I'm trying to show you in this lesson how to think of percent as a proportion, but if you have alternate strategies that will enable you to solve the problem, that is perfectly okay. All right, so when I look at this, I know that 25% of the students like chocolate milk. So that really means that I have 25 out of 100 students that like chocolate milk out of every 100. But the reality is that there aren't only 100 students in the school. If there were exactly 100 students, then 25 of them would be how many would like chocolate milk. But in this case, there aren't 100. There are 500 students. So notice that I've put the corresponding pieces of information on the same side of that proportion, on the same side of the fraction. What am I trying to find out here? Well, I'm trying to find out how many students out of the 500 will actually like chocolate milk. So, again, I thought that I would show you this example to demonstrate how sometimes instead of using algebra or cross-multiplying to solve, it can be actually quicker to use some mental math or to think about these two halves of the proportion as being equivalent fractions. So I would say, okay, well, what did I need to do to the 100 to get 500? Well, I multiplied by 5, and that enabled me to go from 100 to 500. Whatever I do to the denominator, the bottom part of my fraction, I need to repeat that for the numerator. Otherwise, my fraction is no longer the same as the one that I started with. And so 25 times 5, if I multiply those, that will give me the value of x. So x is equal to 125. So remember, with any word problem, you want to state what the significance is of your finding. And so I would say, therefore, 125 students like chocolate milk. Okay, and that's it. In the next example, I'll use the example with a few less friendly numbers, and we'll see how an alternate way to solve that is. Okay, so in this example, an adult red fox is approximately 110 centimeters long. An eastern chipmunk is about 22% of its length. Calculate the approximate length of the chipmunk. All right, so let's draw out some information here. I know that 110 centimeters is like what the full length of the red fox is. And I know that the eastern chipmunk is 22% of that length, right? So I want to know the length of the chipmunk. All right, so I know that the length of the chipmunk is what I'm looking for. And I know that that's going to be 22% or 22 out of 100%. So in this question, what am I calling 100%? Well, 100% in this case is the length of the red fox, which is 110 centimeters. So if I know 22%, 22%, 22% or 22 out of 100 compared to my red box, I'll be able to solve this. So let's solve this. This is not, a case where I can see this really easily as equivalent fractions. That's going to be a little trickier because there's no number that I can multiply a 100 by to give me 110. So I'm going to use the cross multiplication approach. So 100 times x will give me 100x. And then 22 times 110, that may be one that you want to pull your calculator up for. 110 times 22 works out to 2,420. Almost done. I'm going to divide by 100 to isolate x on both sides, and that's going to give me 24.2. So when I work that out, I get 24.2. If I'm approximating, I can leave that to the nearest whole. The question doesn't specify, so you can kind of leave that how you want. I need to remind the reader what the heck that piece of information means, right? What's its significance? So I write a therefore statement. Therefore, 24.2 centimeters, it is the length of the eastern chipmunk. Eastern chipmunk. Okay, simple enough. Just some sort of statement that lets the reader know that you understand what that answer is, what that answer means in terms of the problem itself. All right, so one question that I get when I'm returning tests to students is, well, what percent is that? Right, so I'm going to show you an example that hopefully you can think of this example when you're trying to calculate the percent that you received on any given test or quiz. So in this example, it says on a multiple choice test, you get 4 out of 7 questions correct. What percentage of questions were correct? All right, so I know that I got 4 out of a possible 7, right? So the total number of questions that I could have answered on this test correctly was 7, right? So 7 really represents the 100%. If I got 7 out of 7, then I would receive 100% on that test. But I didn't get 7 right, I only got 4 right. And this is not a case where I can easily use equivalent fractions to solve, because there's no number that I can multiply 7 by, no whole number that is, to give me 100. So I'm going to cross multiply in this case. And what I don't know is, I don't know what 4 out of 7 means in terms of 100 as a percent. So I'm going to cross multiply. So 4 times 100, and then 7 times 6. What do I get? 4x is equal to, nope, let me fix that. 7x is equal to 400. So I'm going to divide by 7 on each side to isolate my x. X is equal to 400 divided by 7. And that works out to be, I'm rounding to the nearest whole. It's like 57.14, but I'm going to put 57, right? So I need to just let the reader know, therefore, 4 out of 7 is equal to 57%. Not that great of a score. So that's useful to tell you, well, did I really understand this well enough, or did I put in enough effort when trying to study for the quiz? All right, so one last example to show you, and I like this example because I think it's one that you actually see when you're out and about shopping, knowing how to take into consideration a sale price, and also remembering that taxes are not included usually on the price tag, but they need to be considered when you're thinking about the overall cost of an item. So there's many ways to go about solving this problem. I'm going to show you one. This is Katie is shopping for a prom dress. She likes a dress that costs $149 that is on sale for 20% off. Calculate what Katie will pay, including 13% HST. So this is a problem that you need to break down into a few different steps. You know what, come to think of it, it may be helpful for me to do this in a couple of different ways, just so that you can see some different possibilities, different strategies, and you can pick whichever one that you like best. So I'm going to split the screen right here, and I'm going to show you option 1. Okay, and then over here I'll do option 2. Okay, so one way of going about this is to first figure out the amount off. Okay, so the amount off, well, I know that she's getting 20% or 20 out of 100 off, but she's not paying $100 for the dress, she's paying $149. Right? So I want to know, well, how much is she paying for the dress with that 20% off? And so I want to know what the 20% off is, so then I can subtract that from the total amount. So when I solve for x, I'm going to cross multiply those values and solve for x. So I end up with 100x, it being equal to 20 times 149, which is 2980. So when I solve for x, I'm going to divide by 100. That tells me that $29.80 is the amount that will come off of the $149 price tag, right? So the price of the dress without tax is going to be $149 minus $29.80. That's before tax. So 29.80 minus, 149 minus 29.80 gives me $119.20. Now the zero won't show up on your calculator. You need to remember, common sense wise, that you know, we wouldn't write money out in terms of 119.2. We would write the 20 cents. So we haven't calculated tax yet, but the way that we're going to go about calculating tax can be done in a couple of different ways as well. So this is option 1 for figuring out what the 20% off is. Okay, and it takes a couple of steps. Another way to do this is to think about it in terms of, well, if you're taking 20% off, how much are you paying? Well, you're paying 80% of the cost, right? 100 plus minus 20% is 80%. So that, you know, you may find that easier, but it's really your choice. But it does save time. So I'm only paying 80 out of 100, okay? Or Katie is only paying 80 out of 100. So what is that amount if she is, if the actual full price cost is $149? So I'm going to solve that in a similar way to the way that I solved it in option 1. By cross-multiplying. And lo and behold, that gives me the same answer, $119.20, or 20 cents rather. I have the same answer, but I've gone about it in 2 different ways. So whichever strategy makes sense to you is the one that I want you to use. Okay, so that's how you can calculate the percent off. Now I want to show you 2 different options for how to calculate the amount of tax. Okay. So, you know, option 1, this is how I can calculate the tax. So remember, it was $119.20, right? And I want to know what the tax is going to be on that, right? So I want to know what the tax will be, and I know that 100% of what I'm paying is $119.20, but I'm paying 13% on top of that, so 13 out of 100. So when I solve for that by cross-multiplying, right, 100 times x, and then the 13 times the 119, so times 13 divided by 100, I'm getting that I'm paying $15 and roughly 50 cents in tax. That's not the amount that I'm paying for the whole dress. So I need to do take a second step here and add in, so the total price will be the $119.20 plus the taxes, the $15.50. Okay, so when I work that out, I'm getting $134.70. Pardon the mess, I'm getting a little cramped here for space. Okay, so that's one way to do it. Okay, so that is add the tax to the price. That's what I'm going to call that. You can add the tax after. Most of you think about it that way, right? Now, another way to think about this is to say, well, you know, I want to know what the total cost is going to be out of $119.20. Okay, so I know that I'm going to pay the amount for the total dress, and that represents 100%, but I'm also going to pay 13% on top of that. So that gives me a total of 113%, okay, out of 100. Okay, so that, you know, you may not immediately think about that, and so, you know, that may not be the strategy that you automatically shift to, but it will save you a step if you think about it. So just cross multiplying here and solving, I have 100x is equal to 113 times 119.20. When I solve for this, I end up getting $134.70. Surprise, surprise. Okay, so notice that I was able to do this question in fewer steps, right? The important thing, however, is that you get the question correct. So the way that you understand how to solve it is probably the best way for you to solve it. Hope that helps. There's some homework in section 4.3, numbers 1 to 8, that you should try in order to solidify and further your understanding of how to use percents.